Woohoo, we are live. This is Math 40 Elementary Algebra, and this is section 3.3. And Godzilla's joining us because we've got a whole color theme going. This is the chapter where we're dealing with graphing. So, of course, I've got my very hard to pick up ruler at the ready. I'm going to turn it the other way so it's easier to pick up. And I've got grid paper. So either have grid paper because you printed this out or have graph paper that you just have. Pardon me. Or you can use a grid that you have online if you have a touch screen or a tablet of some sort. Okay, let's get started. This section we're going to be talking about intercepts. Woohoo! So graph the line y equals 3x minus 6 by finding the x and y intercepts and using one more point as a check. What are intercepts? An intercept is the place where a line intersects. I know it says intercept. It's a slightly different word. Intersects the x-axis or y-axis. So if I have, and this is just a little sketch, there's my x-axis, there's my y-axis, and let me draw in a line, and let me make this the line. Okay, so if that's my line, the point right there where the line I've graphed hits the x-axis is called the x-intercept. I'm going to write x-int. And the point here where the line runs into the y-axis is called the y-intercept. An x-intercept happens when you're on the x-axis, which means y equals 0. So you've got a point that looks like some x value 0. The y-intercept happens when x equals 0. So they're kind of backwards. So it's the x-intercept is y equals 0. Y-intercept is x equals 0, right? Y-intercept is the y-axis. So that's this. So we've got the 2 points that we get if we either plug in x equals 0 or y equals 0. And you'll notice with the last couple of examples, in the other videos, I've started with x equals 0. So it's just kind of something I do because of habit now. So let's try this particular equation and let's see how looking for intercepts can help us graph. If y equals 3x minus 6, and I want to find the x-intercept, I set y equal to 0. And then that will be, and I'll draw a little line here so I'll have some space over here, 0 equals 3x minus 6. So what does x have to be to make y 0? Well, then 0 has to equal 3x minus 6. If I add 6 to both sides, I get 6 equals 3x, or 6 divided by 3 equals 3x over 3, which tells me that 2 equals x. So my x-intercept is going to be the point 2, 0. My y-intercept, that's the point when x equals 0. And this one's actually a little easier. I probably should have started with this one. If I had been thinking, I would have. You plug in 0. 3 times 0 minus 6, there's no solving for anything. It's just y equals 0 minus 6. So that means y equals negative 6. So I've got the point 0, negative 6. So you can tell they're intercepts because there's a 0 either in the y value or the x value. And the next question is, okay, so I got the 2 intercepts. This is the x-intercept because y is 0. This is the y-intercept because x is 0. And then I need to use one more point as a check. What does that mean? Well, that means that if you make a mistake with one of these, your line can go wah and be all weird. So we're going to do a check point. Now, I will tell you that this is surprisingly, and I didn't even realize it, this is surprisingly, what's the word? Contentious. I know at least one other math instructor who thinks this is bunk and this is not the way you should do it. Just do the 2 intercepts and done. So I'm sorry that you're not in their class. I'm sorry that you're in mine because I believe you should check because I make mistakes. So pick another value, any value of x that you could graph. Now, if you pick x equals 1,000,000, it's going to be hard to graph. So I'm going to pick x equals 1. Why not? Because I haven't used x equals 1 yet. So y equals 3 times 1 minus 6. So that's 3 minus 6, which is -3. So I've got the point 1, -3. So I've got the 3 points, 2, 0, and 2, 0. Again, that's the x-intercept. 0, -6, that's the y-intercept. And this is another point. This is a checkpoint. Okay, so I need to draw in my graph now. Now for x values, I've got 2, 0, and 1. So really pretty much in the first and fourth quadrants, so not too big. But the y has a -6. So if I put my line here, I got to be careful that I might not have enough room to go down to -6. So what I'm going to do is I'm going to squish the x-axis up a little higher than normal. Okay, there we go. Now, something cool. If things are crowded over here on the right, go ahead and put your x on the left. You're allowed to do that. You just have to label it at some point. You don't have to label it always on the right-hand side. Same thing with the y. I'm going to label it down here. It's unusual. It looks a little funny, but if you run out of room, it's an option. Okay, I am going to use the standard 1-to-1. So 1, 2, 3, 4, 5. Here I am writing all of them in. 3, -4, -5, -6, -1, -2, 1, 2, 3. Okay. So let's see. I'm going to label this the blue point. Let's graph the blue point. 2, 1. So remember, it's x, y. So x is 2, so I go over to 2, and y is 0, so I stay on the x-axis. Okay. Now where's my y-intercept is right here, the pink. X is 0, y is -6. So x does not go right or left, x stays here, and we go down to -6. So there's my pink point. Okay. And then I'll do yellow for my checkpoint. 1, -3. So x is 1, and y is -3. 1, 2, 3. So it goes right there. Do they lie in a line? Yes, they do. Isn't that cool? And then I hear everyone saying, but wait, wouldn't that work for any 3 points you pick? Wouldn't any 3 points just lie in a line? In fact, you could pick any 2 points if you wanted to. I'm going to label it. I was taught to always label my graphs. So there you go. And if you, and one thing you can do is if that looks ugly to you, you can put a box around it to help give it more visibility, or you could always write it just slightly outside of the grids if you want to make it look less cluttered. But back to the question that I'm pretending you just asked me, which you did not ask me, but I'm pretending you did. Couldn't I just pick any 3 points? And the answer is yes. But zeros are special. Generally speaking, math has 2 kind of parts, broadly speaking. One part is just the math, which is, I think, the cooler part, if I may. The part that has no application, it's just, we call it pure math. You just do math for math's sake. This isn't anyone's heart rate. This isn't the number of cows in a pasture. This isn't how many rutabagas you bought at the store. This is just math. But the other half, the reason for a lot of math is the application, the science, the economics, the business, the medicine, the biology, all the other things. And when we look at the application for math, we see that zeros are very special. 0 as an input can mean the beginning. This can be like if this is at the 0, so the very first day you went out and you had negative $6 in your bank account, but you worked really hard and you got the money up. And when did you get the money up to break even? You got the money up to break even the second day. And then you can follow the trajectory of your money from there. Zeros are really important thresholds. They're boundaries, or we call them boundary conditions in math. So a lot of times they're the most important. Now, what about this point? Was this important? And the answer is not really. However, this was a little rough, right? There's a little work. I got a little squishy. If I wasn't paying attention, if I accidentally, like if I made this -6, I would have gotten a -2 here. Now, if I got a -2 here, this blue point would have been there instead. And my graph would have been, I would have started to graph it over here like that. What does this checkpoint do for me? Well, if I've got the pink point, the yellow point, and then the blue points over here and they don't lie in a line, then it tells me immediately I've made a mistake. So this is a way to literally check to make sure you didn't make mistakes. Now, I hear you asking, what if you make mistakes on hole 3? And if you make mistakes on hole 3, I can't help you. And everybody has days like that, and I'm so sorry if you're having one of those days, because those are just rough days. The math is just not going to be there, you know? Ugh. Okay, shall we go to another page? Let's see what's on it. Ooh, this is getting exciting. Horizontal and vertical lines. So we've got the graph of y equals 3, and I'm going to set up a table of values. The first thing people see about this is they're like, oh no, there's no x. How can we possibly do this? And I would say to you, this is so cool, because if someone gives you a rule, well, first off, before we even do this, you've got to understand, if you don't get to know your math professors, you won't realize that we are the weirdos in academia. We are the anarchists. We are the ones that are, tell obnoxious jokes and like to think strange things. We're really kind of an interesting crew. And so one of my favorite things is when you get a rule that says y equals 3, and my brain starts to play with, is that the only rule? Because if that's the only rule, then x could be 0. Now, y is 3, yes, of course, but x could be -5. But y would be 3. And x could be 17 over pi, which I don't want to have to graph. That was nasty, but y is 3. X could be 1, y is 3. X could be 2, what is y? You got it, 3. X could be -1, y is 3. And then you could say, well, what happens when y is 0? And I would say, better find my red pen. What's the only rule we have? The only rule we have is y has to be 3. X gets to do anything it wants. So this is like a really cool problem for me, because my brain gets excited that the rules, which seem very scary and hard, are actually really, doesn't matter what you do, y has to be 3. So let's try graphing some of these points. Now, I'm not going to try to graph that point because that was just me being silly. This particular equation offers you so much freedom. It's amazing. You can make x anything you'd like. Just y's got to be 3. Got my x and my y and all my arrows. I don't need any values on the y-axis except for 3. Okay, so I've got the point x equals 0, y equals 3, 0, 3. That's going to be right here. And then this is negative 5, 3. Oops, I got to keep going. There's negative 4. There's negative 5, negative 5. Go out to negative 5. In the x direction, 1, 2, 3. There we go. There's my point there. Right there. Again, I'm not going to graph this one. Now, could I graph this? Sure. And I feel like once I've said that, then I want to challenge myself and say, you know what? Do I have the ability to do that? Yes. So I'm going to take 17. This calculator actually has a pi on it. I'm going to divide by pi, and I'm going to get 5 point. Can you see that? 5.411, some other numbers. So it's going to be about 5.5. So we can look for that. That would probably, if I extended this 4, 5, 6, that would be right around here. So when I said we won't graph it, maybe we will. Maybe it's not that hard. Now, is it an exact graph? No. Would I base the rest of the graph around this? No. I wouldn't use this as a checkpoint, personally. I would pick 1, 3, which is right there, or 2, 3, which is right there, or negative 1, 3, which is right there. But then I start to see a pattern. Where's the graph? The interesting thing is the graph of y equals 3 is a horizontal line. Now, what if I said y equals 2? Where would that be? You got it. That would be this line right here, y equals 2. What if I said y equals 5? Well, that would be, if I found 4, 5, there's 5. Y equals 5 would be up here. What about y equals negative 2? Well, that would be down at negative 2, horizontal line. What if I asked you, what's the equation that corresponds to the x-axis? The x-axis is just y equals 0. So if you've got y equals a number, either you remember that it's a horizontal line, or you just try some points and you get that it's a horizontal line, which is kind of cool. Okay, what have we got? Oh, we've got a very similar one. Graph x equals negative 3 by setting up a table of values. This one I find a little bit more difficult, and I think a lot of people do. Because this one, instead of, and now that I've put it away, I want to bring it back out. Instead of getting to choose anything you want for x, x has to be negative 3. So x is negative 3. So what's y? And then we look and we see, oh, wait, total freedom for y. So y could be 0. When x is negative 3, could y be 5? Sure. When x is negative 3, could y be 17 over pi? Sure. I mean, a pain to graph, but okay. When x is negative 3, could y be negative 1? Absolutely. When x is negative 3, could y be 2? Yes. And you see, so y has freedom. As opposed to the previous problem, and I feel like I should write this in because otherwise I will forget to do this later, x has total freedom. So all the anarchists are like, yes! Although I guess it's not really anarchy if you're following the rules, but you're following the rules but hoping that there's a sneaky way around them. So that's it. X has total freedom here. Y has total freedom here. So, oh no, Godzilla has total freedom. Oh no, stomp, 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 stomp. Okay, we're getting a little sleepy, huh? We need to graph. I need to be able to fit in x equals negative 3. So I'm going to be a little thoughtful, and I'm going to put my y-axis a little bit to the right here. Oh no, I took you to Smeary Town, sorry. And then let me put my x-axis right there. Okay, and there's 1, -1, -2, -3, 1, 2, 3, 4, 5, -1, -2. Okay, so where are my points? I've got the point -3, 0. So -3, 0 goes there. And I've got the point -3, 5. -3, 5, that's up here. I've got the point, I'm not going to graph that point. I'm going to skip that point. -3, -1. So that means go out to -3 and down to -1. And then -3, 2. That's go over to -3 and go up to 2. Okay, do all those points lie in a line? Now, let me show you something fancy. The fancy thing is, if you want to make your graph look extra fancy, don't smash numbers. So you see how I drew that -3 right there? I wasn't thinking, I wasn't planning ahead. I didn't just go straight through. Give it a little gap. It'll make it look cleaner. This is x equals -3. It's a vertical line. Okay, so where's x equals 2? Well, that would be the one that's over here at 2, right? Where's x equals -5? That would be right here, where x equals -5. Where's x equals 10? Well, that would be way over here, but it would be a vertical line. And what is the equation that corresponds with the y-axis? That is x equals 0. That's the equation that corresponds to that. Woohoo. Okay, one more. We can do this. I know these videos are getting a little bit long, but this is a pretty quick problem. Let's take a look at it. This is example 8. Using information about a 2010 Toyota Prius hybrid, we can set up the equation, and I'm going to write down my own version of it. 12m plus 600g equals 7,200, where m represents the number of miles driven. So m is the number of miles driven. So that's miles. And g represents the number of gallons of gas left in the tank. Okay, so that kind of makes sense to me, right? As you drive more, the number of, so as you drive, let's see, drive more miles, you've got less gas. Does that make sense? Even with a Prius uses less gas, but still, if you drive more miles, less gas. If you drive fewer miles, the gas doesn't go down as far. So you've got more gas. More miles, less gas. Find the intercepts for this line and explain what they represent. So it's not asking us to graph it, just to find the intercepts. So let's do that. Let's find m equals 0, because I just did it first because it's the first one. So 12 times 0 plus 600g equals 7,200. That's 0, so we've got 600g equals 7,200, or 600g all over 600 equals 7,200 over 600. So g equals 12. So when the number of miles driven equals 0, g equals 12, and that's gallons of gas in the tank. Oh, well, I think what that's telling me is when we started, before we had driven at all, so at the very beginning, we had 12 gallons of gas. Had 12 gallons of gas. Okay, I'm going to need another piece of paper. So let's look at the other the other one. So 12m plus 600g equals 7,200. So the next one is what happens when g equals 0. So let's take a look. 12m plus 600 times 0 equals 7,200. Well, that's 0. So we've got 12m plus 0 equals 7,200, or 12m equals 7,200. Divide both sides by 12. M equals, and I think it's 600, but I am too tired. So I'm going to double check. There is no shame in double checking. 600. So when there are 0 gallons of gas in the tank, that's weird. The mileage is 600 miles. Okay, that's weird. What the heck does that mean? So take a moment to, you can yell it at the screen. Screen, not screen. Yell it at the screen. I'm listening. Oh, that's a good idea. That's a good idea too. Okay, so let's take a look. What does this mean? When there are 0 gallons of gas in the tank, the mileage is 600. That's weird. When would there be 0 gallons of gas in the tank? Well, if we started, oh no, I lost my other, there we go. When we started, we had 12 gallons of gas. So now there are 0 gallons of gas. So what do you think happened? Yeah, we drove. If we drive until the tank is empty, we can drive for 600 miles. The range, that's what people call it, the range of the car is 600 miles. So when we look at the zeros, it tells us at the edges, if we go all the way till all the gas is gone, we could go 600 miles. If we go all the way back to the beginning, we find that we have 12 gallons of gas in the tank. You guys are awesome. Woohoo. Okay, so next up, we've got one, let's see, that was 3 3. So we're going to be talking about slopes and rate of change. Ooh, that's exciting. We're going to be talking about slopes. So get on your ski clothes and your ski pants and your skis, and we will go up and down mountains. Woohoo. Math on, guys. Math on. Video's over.